That's fine. Okay, guys. Now, today what we're going to discuss, like we are going to discussing about the how to install Kubernetes cluster on Ubuntu instance, okay, in Amazon cloud, okay, Amazon cloud and Ubuntu instance, okay, and Ubuntu instance we're going to do. And remember to set up your Kubernetes cluster on Amazon cloud, okay, you need at least T2 medium resource, okay. T1 like as you know T2 micro is won't enough, but which is we are getting a free resource from AWS, right? That's not a, no, that's not enough. Now at least we need a 2 CPU core and 2 GB RAM needed. Now that's the reason we are going to choose this T2 medium. Unique, that's a mandatory. Okay. Now slaves, that's fine. Slaves is T2 micro is work out for us, but you know master is mandatory for T2 medium. Okay. Now how we're going to do that? Let's gonna create that T2 medium instance first. Okay. I'm going to launch the instance. I'm going to do that. Okay. I'm going to give the some name for my instance. Okay. Now one instance and see, I'm going to take Ubuntu instance and I'm going to choose that T2 medium here. Search with the T2 dot medium. Okay. And keep it, you can select which you have existed one, or else if you don't have, you can create a new one. I already have. I'm going to select this. Okay. And remaining like as we're going to enable the ports which we needed going forward. Okay. Now there is a like as Kubernetes API server, some port need to be opened, and like as you know, like as we have a etcd, some ports we need to open, like as multiple ports we need to be open. I'm gonna show for later for which component needed and which port is required. That will do later. Now, as of now, 8 GB is enough for right now for storage. Now let's just simply launch the instance. Once the launch instance, let me open our documentation. Okay. Now, okay, let me open this. Okay, this is same setup is not worked previously. Like there are some few changes that happened recently and a latest version of Kubernetes cluster, which we have previous session or whatever we have. That's not working out. Okay, now I'm gonna do for this fresh one, and this document is updated one. Okay, now this is what I have written was some important points to understand. Okay, to like as you know how much which kind of instance we have to take. Okay, and all the things. Now this IP range is fine. That depends on your private cloud network which we have set up VPC. Okay, that we discussed on our AWS course right the last week. That's fine. Okay. Now this is the control node. Like as we discussed the Kubernetes architecture, we have a master node few components and nodes have the few components. Like come to the master node, we have a like as API server, etcd, and then scheduler, controller manager. We have components and each component explanation we already done that. Now those components we're going to install today. Okay, now first of all, once we have taken a new mission, let's connect that. Okay, let's go to instances, filter with running. Okay, now select, let's connect the instance, open switch, open the mobile system, and I'm the path of jmsth39.pm file. By default path is that. Now let's connect this. We have connected successfully, right? Now let's do that. Follow the same document if it works for you also. Okay, now let me close this and let me open this, and let's update the first. When you take a new instance, let's update if you have any dependencies need to be updated. Been update. Next, these are the dependencies need to be uses for our Kubernetes cluster like HTTPS and CS certificates and curl for downloading something. If you already have it, won't do anything. If in case if not there, it will be installed for us. These are the dependencies are mandatory. Let's install this. multiple dependencies at a time. Okay, like it's each are individual. Like this is the different. I mean till this. Okay, and CSS certificates are different and curl is different. These are at a time. Next, what we're going to do? I'm going to creating one file. This file. Okay, and I'm writing it like as end of the file using T will be do for print the file and then console both at a time that we discussed in our Linux course, right? Now I'm closing that here. What it will do? It will create a one file. What file it will create? Let's open this file. If you open this file, now this is the okay. We are net. Okay. Now next, what we do? Let's open for another file. Need to be open for this IP tables. I need to be close that end of the file. Like let me type. Okay. Once we added that, see the T command will be print file as well as in your console both. Just to confirm it. Okay. Now you can see this. No, why we need this? Execute the following command for the IP tables to bridge traffic. For the bridge traffic purpose, we are going to do this two commands. These two files we are going to create. And next, what we do? Disable the swap. Okay, if you have swap memory anything, you can disable that in the system. Next, we have a multiple container runtimes we have, and you can disable for any runtime depends on your requirement like as container D, CRIO, Docker. Okay, I'm gonna do with the Docker and whatever you are preferring, then you can use. Earlier we do actually Docker most of the time. Now going forward, maybe in future they are not supposed. They mentioned that, but not sure it's not at there. Declared the Docker is not supporting. Maybe in future, maybe not support for Docker, and maybe like as container D may support and CRIO container runtime maybe supports. Okay. Now let's see. But as of now, Docker is works. Okay. May I don't think so. They're gonna remove, but yeah, we have a announcement. They're gonna deprecate it Docker. It's a deprecated, not removed. Okay, on Docker, but still works right now. Okay. Now let's update the. If you have any updates, then try again. Thing is there. That's there because we added for the few things, right? Subject, and these are the like we already done that these two curl and okay, gnu pg and like release lsb release. Now these dependencies I'm installing. This nothing is there, it's already there everything. Now what I'm going to do, I'm going to add the docker gpg key from the which repository to be downloaded. Once it is done, let's add that where we need to be download these gpg keys, and then from url, and then which version, and then put into the terminal. Once done, then now install the docker community edition. We added the repository URL and then we are installing now. By default, we don't have a Docker, like as community edition in your system. Okay, in Ubuntu, it won't come. Then first we need to add the GPG keys and the repository URL, and then let's install. Okay, next, add the Docker daemon configuration like system D and C group driver. Now this is the what we have to be create one file again. Same what we do. Okay, this is not required T command to use mandatory. Okay, that depends, your wish. Like if you execute this, if you're not using T command, what it will do? It will directly store in this file. It won't print in your console again. If you want to see the console again, just use this option. It's a good to use. Like just it will print that what file is created, just in the format. Okay, in your console. Even if you open the file, it was the same. Cat, it was same. Okay, it was same. Fine, just confirmation reason. Okay, then like let's enable the systemctl docker. It is will get a symlink for this. Okay, and daemon reload this. Now let's restart the docker, and like it's done. Now next, the Kubernetes dependencies we are installing: KUBEADM, kubelet, kubectl. Okay, we already discussed. KUBEADM is the components which we are installing, and kubelet is that every node should be run, and kubectl is the command line utility to manage your Kubernetes cluster. Now let's update this. If you have anything updates, let's stop. There is, there is packages are updated. Next, let's add this GPG key for Kubernetes. A complete command. This is complete command. Okay, let's do this. Complete command. Okay. Next, add the GPG key for apt repository for Kubernetes. So everything is a single command again. Next, update the install kubelet kubeadm and kubectl. If you have any updates, then try it again. Good to use for update command. Like it's after adding your repositories in your system, first update that. Then only it will add it for your packages. What are the new packages you added, right? That will packages will be added. See, Kubernetes release all those things. Okay. Next, let's install packages. Okay. Next, okay, once it is done, then remove this config.tom file. By default, will create one file in the container engine. I'm just removing this because it's, or else no, the Kubernetes cluster won't be started. Okay, now let's restart the container after removing the tom file. Container is also restarted. Now we have all the required utilities and tools to configure Kubernetes component using KUBEADM and create an image. The setup what we have done, just create image because this image I can use for in future again Kubernetes cluster setup, or else even node also need to be installed, Docker node also installed in there, like some dependencies. Node also needed for some let's say all our kubelet also needed. Okay, all those you don't want to do, you can use the same AMI for the creating a number of slave nodes also. Okay, now I mean like yes, the node Kubernetes node cluster, right? Now that nodes we can use that. Now I'm going to create one image from this existing setup. Now let's go ahead here, select like as action, image and template, create image, and let's create image. Okay, next here is 39. Okay, and kmaster, just give this kmaster. Okay, that image description, Kubernetes master node, let's whatever, and then select this. Okay, no reboot enable, because or else if you not select this, what happened, right? When you create image, your system is restart. Then if you restart, then what happened, right? When you start the Kubernetes server, then what happened, the port is already binding, the error will come. Okay, then again you need to be reset the your Kubernetes setup, and then again we need to be start again. Okay, instead of that, let's select this. It will be simple for you, and then create image. Okay, 8 GB is enough, like whatever the storage is there, then you can't make it for less than this. Okay, you have to be give that whatever you have to create the instance, that mandatory. Now create that. Now see here, it won't be disconnect, it will be keep on live for this. Okay, if you select that option, great. Next, what we do, let's go ahead and then like this step is done. Now how we are done, that's all the steps we have written here. Next, what we do, let's set up this, let's make a all this packages should be hold it here. Upgrades for two like we are, why we are holding this, to prevent the upgrades. Okay, making hold. Okay, all this, and next initialize the Kubernetes kubeadm on the master setup and control plane. Now for this, what we have to, you need two environment variables. One is that IP address and node name, and these two I'm gonna select. And remember, this you have to be changed for depends on your system. Okay, and in this my case, what is my Kubernetes master node, I have private IP. Then I'm gonna set up this. Now select your instance and go to your private IP. Now this is my private IP, because this is a private IP, never gonna change that. Okay, now copy this two. This is fine. Like copy this two and then paste it in your. Okay, that's fine. Copy with the dollar also. Just remove this dollar. Now let's copy this and then paste this. Then, Now we can set up for env and check whether grep, okay, like as node name, the environment variable setup, it's set up. Okay, it's set up. Okay, if it's temporary, then if you want to make it permanent, you can use a bash rc file, then those will be permanent, will be fixed that. Now let's do this next. Now this, let's create a like as C group driver. Then how to configure your C group driver. Then we can refer this document, and I'm going to create one file, va config.ml file, and this is the where need to be checked. Earlier it was different version to works. Now it's a different. Let me open this API version. So beta for this object. Kubernetes configuration is same, but that cluster configuration it was changed. V1 beta 1 was there earlier, V1 beta 2, and now it's a change to V1 beta 3. Okay, that is a change happened. Now paste this. Now this is the pod subnet mask, and we discussed in our AWS course, right? Like yes, this is your wish, like depends on your wish. Okay? Whatever you want, you can give this 10 dot something range. Okay. Now you can do 1.0, then your IP pod will be get 1. Like a 10.1.00. Like 16 means how much range it is. Like as what is the like as IPs will be allowing 16. Now if you like as it's a more range, like you want to make it a less range. Okay, we already discussed an IP address guide in our AWS course in VPC discussion, right? If it's 16 means like as see here, right? What is the starting IP? Ending IP, and see 65,536 IPs, we are going to allowing that. No, sir, that many pods we are not creating, we are going to creating very less pods. Okay, then I'm going to give the less subnet mask. That depends on your case. Like in this case, I'm giving this huge. Okay, in case if you want to then do the 24 or something, like if you are running the, that's fine. Now save this. Okay, save this file, and next, once it is done, the next let's initialize the your Kubernetes cluster. So this is very important, and you have to pass your config file what you have just created. Now it will do this, take some time to getting up. Now let it be create. Let it create. Now it will give a few like as commands that we need to be run again. I'm going to show do that. What are the command to use to check whether your cluster is up and running, like as how do you check your application components, master node components, okay, and where which namespace it is created, what is the namespace, what is a pod, okay, that we discussed already. What is a pod, right? Now today what we do, let's see that how to check the pods, how to check the deployments, how to check the services, how to check the replica sets. Going forward we are going to do anyway. Like first, as of now, we check for like as node cluster you have, right? You want to check that kubectl. Now we are using the kubectl is a command line utility to manage your Kubernetes cluster. Now going forward, what we are going to do, like as we make it, our life is simplified, right? Like we are using some tools like KNNS, something like that. We don't want to type this much like as lot of commands, right? Whereas some people, what they do, they can make it a alias names for these commands they are executing. But every time, like for example, you like as every time you execute you will remember, but some commands you forgot them maybe, right? Now if you know, if you do the KNNS like as a vim editor, like how to manage your vim editor, that way we can use very simple, very simple to open the search, terminal, like a shell, and then restart the pod, restart the deployments, delete the pod in a single command with single key. It will be helping for us. Okay, I'm going to teach that KNS soon. Okay, like once we are expertise on our Kubernetes YAML files, manifest to write, all the things we'll discuss that later. Okay, now see this kubectl get nodes, execute this command. Now it will give that like as it's showing that could not connect API list, and then let's open this port 8080 port in the system. Now you see, no, yes, second. No, we will get this error. Okay, let's 8080. Let's what to do now. Let's first of all let's create a one or kubeconfig file. Now once you get this error, then create this. Now set up up this now. Now set up this. Okay, and next let's try now. Will get nodes. Now see this. Now one, this is the everything will be there, and then we have a jan command. Let's take a backup of this. Even if you forgot also, we'll have this. Why this command is used? Basically this command we are going to use to connect our nodes to master. Okay, this port with this port means we need to open the 6443. This is what is this port? This is the API server port, because as we discussed previously, our API server is the first most our REST API which we are gonna submit our manifest file. Okay, the manifest file, how we are gonna write it? We are writing as a YAML file or a JSON file, but mostly 99% we are gonna write for YAML files. Okay, but output we can see in the JSON very easily. Even if we want to extract the data, you can use the JQ terminal. Okay, like there's a lot of tools we have to get the exact values. JQ is the best tool to get from the JSON data. We'll get YAML file format JSON output also. We'll see in the future. No, that's the reason we need to open the 6443. Okay, and see here this API server API group also will be using the port number 8080. Okay, now let's open these two ports 8080 and then 6443 in the master security group, and let's open this. Edit the bundle 8080. Now you want to connect your, let's, this is optional, you can ignore this in case if not required, and 6443 is the mandatory. Okay, and to connect your nodes. Okay, that's fine. And I've already written for the what are the ports needed for what. Okay, you can go for above and refer this all the like master control plane nodes, and this is the official document I have taken. And 6443 for Kubernetes API server, and 23792 2380 two ports, which is for using for our QL page store is the etcd. And next 10250 is the kubelet API for self control, and 0251 is for kube scheduler, 10252 for kube controller manager. Okay, this is the ports need to be used for your like as control plane. Okay, now let's see here. See what happened. Our node is not yet ready. Even you can try again. You still get node. It will give our node information like as how much node we have, like as how many nodes you have in your Kubernetes cluster. Okay, KUBEADM cluster, right? Now let's see how why it's not running. kubectl get pod. If we give the pod, what it will do? It will give the our default. By default you get the pods from the our default namespace. But how do you know what are the namespace of the kubectl get ns? If we do the get ns, it will give the list of namespaces we have. When you do the namespaces, by default we have these default namespaces we have when install the web Kubernetes. There is a four. One is the default kube node lease, and then kube public and kube system. Now all the system related components which is running on the kube system. Now let's see this kubectl get. Okay, now let's see that. Now we can do for -n and then kube system and pods. You can do this way also. POD or PO, anything will work out. Now see this. Okay, RS what we do, we can, if you want to see all the pods, okay, instead of this get pods hyphen capital A, if you do this, it will give all the namespaces pods actually. Okay, all the namespace pod, even kube system or kube public, if anything is there, everything will be, all the namespace pods will give. You want a specific pod, you want to specific namespace you want to see, we are going to specify hyphen n and the namespace name, and then like as what you need to do pods, and you can try with the deployment. Okay, pod and the replica set. Replica set means you can define with the RS. Now see, this is a two replica set, which only one replica set which is running on, that is a core DNS, and that's the reason we can see this in the core DNS is running on the two components. Okay, this is a replica set, two pods mandatory in the core DNS. That's the reason it is running the two pods. Remaining is running the 111 components. Okay, this is the only one replica set we have. And then see this, and if you see the deployment, you can see the deployment components. Now only core DNS is the one deployment, remaining is the like as what it is in the pods which is running on for us, these components. Okay, the code is only one deployment we have. So then how we know like as each component for why it is like what component is running on, like basically we install that Kubernetes cluster, right? There is a, okay, let me show this. We have an URL for to see this content, right? I already shared with you last time, right? This is the dashboard components. There is a what are the master node components we have. Okay, this one. Okay, now this is the this one. For example, this is a different actually. Sorry, this is for wave network that we are going to do later. Right now we are doing now in a Kubernetes. When you do the you see group driver, that in this like wherever we are this URL, from here it will be download like from this somewhere. I'll share that at the end. Okay, now let's go ahead moving forward. So from where it will download these components, KUBEADM components. I'll show that. I'll give the link with you guys. Okay. Okay. Now next, let's go ahead for where we are right now. Now let's see here. Now there is a two components are not running. Why it's not running? Because of there is a network issue. Like we need to install the networking CNI plugin. We need to be installed. Now what are the CNI plugins that Kubernetes will support? There is like a number of will support. Now let me show this. Kubernetes CNI plugins. Okay, now there is a lot of plugins will support. Okay, people will talk different plugins. Okay, this network plugins. Now we have a lot of. Okay, see this loopback CNI. Okay, now support traffic shaping. Okay, this is different one. 1 second. Uh, okay, now let's see this install items. These are things you can see. ACI, Antria, Calico, Canal, okay, Cilium, CNGeni, okay, Can't you, Flannel, and let multiple things we have. Okay. Now one of them is that we are WaveNet that we are going to installing right now to see those to set up a CNI network. Let's do that. Okay, that's to making this. Now this we already done that. Now this KUBEADM Jan command we are going to do later, and this is we are done. Now this is CNI. This is the pending. Okay. Now we are installing the CNI network. Now do this because this is we already enabled. That's not required because this step we already done that previously. Okay. This one if you cannot you can see copy this. Okay. And we are done here. In case if you want to set up, then set, like check and then set up again. If you missed, okay, we already done that. That's not required here. Okay, this is the output. Okay, when I run the CNI command, this is the output will be printed. These are the output. Okay. Now, then next, if you are not enabled, just try to this too. Okay, we already done that and not required. Now I'm going to set up the version here, the Kubernetes version. Okay. Now in case if not work, let's say for example, it's a duplicated. Now it's a duplicated version if you were getting. Now in case if you done that, if not work out, then try it out. Now what is that URL? What is this content? What are the components are there? Just copy this URL, then try it out. Check. This is the YAML file will be show for us. The wave network. What are the objects? What are the components which contain? Okay. This is the YAML file. Anyways, show in the folder. Open this. See here. Okay, now let's see here. There is a service account. Okay, there is a cluster role. Okay, like all the kinds you can see. This API version, this API version, this API version, you can see this. Okay, this many. Okay. Now you can see the first API version is the service account, second API version for cluster role, and another API version for cluster role binding. Now these are the components: the role binding, cluster role bindings we have. Next role binding, and next demand set. Now these components will discuss like what is the demand set, what is the role, what is the role binding, further. Okay. Next, we'll do this. Okay, for these are the components where like these are the objects in Kubernetes, like as role binding, cluster role binding, demand set, all those job, cron job, deployment, replica set, stateful set, okay, persistent volume claim, okay, all those different kind of components, objects are there. Those objects will discuss one after, like every day, one or two objects in a day. Let's do this next. Okay, now once done, let's copy this and then apply this. If not that's duplicate, just use this one, anything will work. Okay, now see, these are the object. Service account is created, cluster role is created, and the cluster role binding is created, role is created, role binding is created, demand set is created. All these objects are there. Now how do you check this each individual one? Then we can use the kubectl get role. For example, if you try, it won't come anything. Now if you try with -a, or else no, just try with ns. Now see this. Now this is the fourth, right? Now you can try with ns, get role, get role -a. If you can get all, you can see this wavenet is created. Okay, and here, so this is a role we created. Okay, not it's like that. We have multiple roles are even previously also created. Now this is the one of the role. Okay, now we can get for all the pods from the namespace, from the -n to system cube system namespace. What are the components are there? You can see this. Okay, these pods. Okay, and then the pods. Okay, role binding for the specific namespace. You can get that. It's very simple commands, right? Now, yes, we'll do like every day. If you do hands-on, then we'll get easily this. Next, once we are done the get nodes, let's try with the get nodes now. What happened? Now, previously it's pending state. Now, let's see what happened. What is the state of right now? Now, it is ready. Our control plane is ready. This is a control plane means master node is ready now. Now, which version we install? Like 1.271. That is the latest one that we install. Now, let's see. This is one like a namespace person. That's what I just given the commands to understand. Next, once we are ready, everything is ready. Okay, let's go ahead and then create a agent node. Okay, you will do the KUBEADM team, like you see this, and any of the security group, the master node allowed to this 6783, 6784, and 6784 for UDP port. Okay, TCP port and UDP port for this wave network to join this. Basically, this is the wave network ports need to be open. Okay, now let's open this. This is a wave network port needs to be open. Now there's a few nodes, like if you want to shell few nodes, like QAPA server nodes, all those ports also you need to open. Okay, then right on to connecting the server, this is the port is required. Okay, 6783 for TCP. 6783. Okay, like anywhere. And CH 6783 for UDP also. UDP port. Let me open the UDP port. 6783 for you. Okay, and then and 6784 is a UDP. Is at the UDP port. Okay, anywhere you can see this. Now save this rules. Once the save this port open in the system, next what we do? Okay, like if for example in case if KUBEADM join command if you missed, then you can try it out to generate a new token here. We already have a taken backup in this join command, right? In the notepad we already took backup of this. In case if you miss that KUBEADM join command, this command is missed, then what you need to do? You need to be run again this command. You will get the join command itself. Now go to master node and then execute this. This is a giant command will be give this. Same command will give this. Whatever we have taken backup, the same command will give. Then we can use this command and then I mean like as maybe this token may vary, but yeah, it will be help us to connect your nodes. Okay. See here J2 something, right? It's a different. This token is different. Okay, but it was correct connecting purpose. We can use this. It will generate a new one. We can generate, if you generate a new one, what the command is generated. Now don't use the same command what I have typed in this document. Okay, don't use this IP, this this token for my, when I've written the document for my cluster. Even this won't work for right now for me as well. Okay, for me also it won't work. Now you have to be create a new one for based upon your system setup. Now in this case my setup is this. Now I have to use this one. I have to use this code. Okay, now I'm gonna use either this, anything is fine. Where I need to connect, I need to create a nodes here first. Let's create a node to joining a cluster. Like as know what happened, right? By default, Kubernetes cluster, it won't deploy any workload. Like for example, if you deploy any pods, any application in this master node, the master node won't be accept for your workloads. It will be needed a nodes actually mandatory. Slaves are mandatory. This we can, why we can call slave, because we are aware of master slave operation Jenkins and all, right. Just I'm explaining that way. Okay. Now we can add the nodes. That nodes will be manage your workloads. Okay, because it's a tainted by default. The node is tainted, master node is tainted. Okay, we'll discuss what is taint, what is the toleration, all those in the future sessions. Okay. Okay, now let's do one thing. Let's create a nodes here, instances, launch instances. I'm going to do at a time. Okay, at least I'm going to take a 3 node cluster here. This case 2 nodes. Okay, and this one k node. Okay, let's just, I'm going to type the k nodes, let's say. And I'm going to do for my ms here, I'm going to select for, this is K master, the one which I just created. It took some time to create, but right now it is ready. Then I'm going to use this. Check your go for AMI and then ready. And I'm going to use the same key. Then you can use a different key in case if you have. It's fine. Okay, this is, everything is fine as of now. Just create. And remaining ports are open. 2 no ports that we'll discuss later. No launch instance. Okay, I select for T2 micro in this case. Okay, just it works out. Your T2 medium instance, but T2 micro will be, AMI is fine. You can use a medium or whatever it is size, but the next instance type, whatever you do, that will take. See here. Sorry, not this one. Filter this running. Now see here. It takes some time to coming up. See in the nodes, the first one T2 micro, and this is the T2 micro. Now let's try it. Oh, connect the servers. Okay, let's connect this node. Either if you want, you can do this one thing, like you can do for node one and rename this to your node two, something like that. Okay, now if you connect the node one, let's connect this. Okay, this command. Let's put this and connect the node two also. Right? Yeah. Now what happened? Problem, like when you create a instance through AMI, by default username will be a root, but the instance username is the Ubuntu, right? Now change that, don't copy paste that directly, it won't work. You have to change to Ubuntu. It works. Same here also, control A. If it comes starting, Ubuntu. Because it's a Ubuntu UMI, right? Yeah, it is a default user Ubuntu. See, the 2 instances are ready now. Okay. Now we discussed in Ansible, right? Like if you are want to execute a one command multiple nodes, then you can use the Ansible to do the same similar job, right? In our Ansible course, we learned that, right? In this case, it will help us that command to run this command multiple nodes and all, right? This Ansible is the one of the scenario. If you have 100 nodes you want to run the kubeadm join command, then what happens? This is now what how real time will do. Basically, this giant command we are gonna give at the time of your, like as auto scaling, like we discussed in AWS in auto scaling, right? In auto scaling time we have the, like it's at the time of booting your script will be run. In advanced section we are gonna add the user data. The user data we are gonna give the script. The script will be create to join the one node. That's simple. Okay, that will be done by the auto scaling, right? Like as like we discussed, and the launch configuration, right? We have to create either any one of the templates or launch configuration. we are done. We discussed already that in our auto scaling in our AWS course. Okay, fine. Now see here, let's update this. If you have first sudo apt update -y, do the same command here. See if you have any updates, it will update. Okay, once it is done, once it is done. Okay, now next what we do, let's go ahead and then use this command. Either we can use this command, anything, the giant command, then go on take this command simply. Either anything will work, both will work. Okay, I'm gonna use this. Now see here what happened. This KUBEADM giant command 6443 is not allowing us that because this system need to be okay. Now it is not running as a root. Yeah, basically you need a sudo command while executing this command. You have to be use the sudo command. Sudo this KUBEADM giant have to be in the root. Okay, now sudo, sorry, see here. Now see this these guys are giving the command also. What's command need to be executed in the master node need to be executed. Okay. Now see, one master node is ready and one control node is ready. Like as you know, slave node is ready. Another one is waiting. It's also ready. Now we have a three node cluster. One is master, two slaves. If you want to add on one more, simply nothing. You don't do anything. Just simply use the AMI to create a number of instances. Very simple, very straightforward, right? Now we have very easy to create. Now even sir, instead of copy this command while creating instance in the user data, can I use this command? Obviously, that will be very simple for you. Just update command. Next, use the kubeadm jan command at the time of while creating instance. That is the way we do in a real time. Okay, like as after creating instances, you go for manually updating the kubeadm jan command to jan in your cluster. That won't work out in real time, right? We don't know when the node will be come up, when the node will go down. Depends on your load workload. The nodes will high, nodes will be low based upon your auto scaling setup, the node group setup, right? We do that. Okay, fine. Even I'm gonna show for how to do that. Like in AWS, like as we have EKS cluster, right? How to create EKS cluster, how to create a node group through AWS console, as well as we do with uh, we are going to do with our Terraform also, and we are going to do with the EKCTL also. There is a three ways to create a Kubernetes cluster in our course. We have it documented, and then we are going to do this. Like one console way we are going to do in the late, in AWS course, and one we are going to do in the Terraform through Terraform code. Okay, one is that in this course, like how to create your like as EKS cluster through EKSCTL tool. There is a one more CLI tool which will be third party tool, but it will be announced by the like as Kubernetes Linux Foundation guys will be saying that is official tool to manage your Kubernetes. Many companies are using EKSCTL to creating their clusters in Kubernetes clusters. Very simple, single command to create your Kubernetes cluster. It's very easy and it's very handy to use that. Very very simple, very simple. Now today we are said like as spending almost nearly 1 hour of time to set up a Kubernetes cluster, right? If you use the EKCTL tool, it's just a single command. Within a minute, you can create a Kubernetes cluster. Very simple, single command. One, even that configuration file you've written or not, that's fine. You can use a single EKCTL command, and it will be done for you. That we're gonna do that within a minute, but I won't tell that right now. First, practice this way. We'll learn that later to manage. Very simple, but that is chargeable again. Okay, it's a very less charge compared to the EKS setup. It's very very less. That is very more cost. Okay, that's the reason I'm not teaching that right now. That we'll do at the end of the course. How we can manage your Kubernetes cluster, in EKS cluster through EKCTL tool. Okay, that we'll discuss later. Fine. Right now, our Kubernetes cluster is up and running. Our Kubernetes cluster is up and running. Let's do one simple deployment. Let's see how application is running or not. Okay, just do that. Okay, we are not doing any like service deployment. Like if you want, we can, I'll show for service deployment and deployment object both right now. But what is that and how it work out? What is the pod? What is the replica set? What is the deployment? What is service object? There's a lot of need to be learned first to understand that. Okay, just what I'm gonna do, checking for our pods in default namespace to deploy something in our default namespace. I'm gonna do that. A simple deployment. Either we can do declarative way or imperative way. Declarative way means now we are gonna create a one YAML file and apply that. Imperative way means simple run a one kubectl run command. That's it. Okay, that way. Now what I'm gonna do, I'm gonna like we have a few more pending things. Now we have a dashboard setup that we are gonna do later. Maybe tomorrow I'm gonna teach you like how to set up a dashboard for Kubernetes cluster. We have a dashboard to see how many parts are running, to restart, to see go to the console and console output. Okay, deleting pod, lot of options we have there. Okay, and we'll see that which namespace we have. Very simple, very easy UI you have that we're going to deploy this. Very simple. There is a four commands to run. That's it. And we need to create a cluster, our custom service account, custom role, cluster role binding. All those we're going to do this. Like this, we can see the UI that I'm going to show you tomorrow. Okay. As of now, let's deploy a simple way. This is a few commands are pending that I'm going to show that tomorrow. This is for only for creating a dashboard. How to create a dashboard for Kubernetes cluster. But right now, to practice, to understand, to executing any manifest, this is still is enough to practice your Kubernetes. Like you are preparing for Kubernetes administration, Kubernetes application developer, or like as security specialist for Kubernetes. Any you are preparing for an exam now, you do the first setup. Now can use this setup and practice and then write an exam. Okay, fine. Next, do one thing, let's gonna do for our first deployment. Okay. This document, I will see this later. Now what we do, let's go ahead for, there is a practical document we have. Installation, there is a one document, just give me a minute. There is a practical lab practice is there. Okay, the lab practice on Kubernetes. Okay, just simple. You can, this is the like as a imperative way, that what I'm saying. Okay, or else if you want to do declarative way, that's a different again. You can, this is the declarative way. For example, you want to deploy a deployment object, then we can do this. Just deploying Nginx server. Okay, what is this syntax and all? Don't confuse anything. We're gonna discuss each and every line of this API server. What is the kind? What is metadata? All those we're discussing now. Next, further. Okay, this is simply I'm to understand you guys like how our Kubernetes cluster is working or not. Just I'm doing this. Copy this manifest file and paste. Okay, now this is the four sections we have for like it's our manifest file, either pod, either replica set, either deployment. We have four components. One is API server, kind, metadata, specs. Okay, in the spec, because of deployment object, that's we get a replica set extra. We'll discuss each and everything difference between pod, replica set, deployment object. Why these three we can return in a single YAML file. If I use the deployment object, we'll get a pod, we'll get a replica set, we'll get a deployment. If you do the pod, you won't get a replica set, you won't get a deployment. If I do replica set, you will get a pod, you will get a replica set. Okay, this is the way. Okay, like as first one is the pod, replica set, and deployment. If you do deployment, 3 will come. If you do replica set, 2 will come. If you do pod, the kind pod, then only pod will come. Then what is the advantages of pod to replica set to deployment? There is a difference. Okay, why we need pod is like we don't have, we discussed already theoretically that, right? Initially the pod is like not a live, like it's not a completely running on, right? One pod will come, one pod will go, right? One new pod will come up. Okay, then it's not a standardized. Okay, it's not a, it's not a model, right? Now to manage your, like something goes down, who will create that automatically? That replica set will create. If you say that are mama, like I want to run one pod at a time every time. Let's say even one will go down, another one will come automatically. Because of that, it will be taken care by three replicas. If you not mention this, if you use the pod, then your pod will go die, means that die. No one will be created for you. If you mention the replicas, then either you can write a deployment object, either replica set object, then by default one pod will be created for you. In case if you want to two, two will, three, three, four, four. Just number we need to change. That's it. Okay, if you do the deployment object, there is a like mean surge, max surge. Okay, there is a lot of features will come that we'll discuss in depth, further moving on. Okay, what will do the mean surge and max surge, rolling updates, rolling updates, there is a lot of options we'll get. Okay, we'll get. Okay, we'll discuss that rolling updates. What is the use of that? Okay, all those things. Now let's see, save this file and let's do deploy. How to deploy this YAML file? So this is we call as a manifest. We can written as a YML or JSON anything. Now how do we deploy? kubectl apply -f and then nginx that file. See this is deployment object. When you create a deployment object, kubectl get pod, if you can see our pod will up and running one pod because of one replica we mentioned, right? Now if you see get you know deployment, you can see the deployment object. There's a one deployment is in, one is running, one pod because of. If you see the replica set, rs because of you deploy the deployment object. That's the reason we got a three. If you do deploy only pod we can see. You won't get any deployment of you won't get deployment object. You won't get the replica set. To access this application, you need a service object. To see your application is running or not. Okay. Now kubectl get svc. If you see the service object, you don't have. Why this service object? Why? What is the use of this? That we're going to discuss in later. By default, nothing is service object is created. Just to understand our application is deployed, is able to running or not. Just I'm going to show this application. We'll see later sessions for to how to create a service object. What is the use of service object? Okay, why can't we access the pod IP? Okay, what is the drawback over there? Okay, there's a lot of subject we are going to discuss. This is just we are setting up our cluster. Means our cluster is working to confirm that our application is running. Now, how to access this application? That's a different scenario. Okay, we need like what is ingress controller. Okay, what is the namespace? What is the like? There is a lot of objects yes, involved in our Kubernetes cluster. One by one, we're going to discuss. And tomorrow we are going to talk about our how to create a dashboard for Kubernetes, and we're going to create for first most the initial start of our YAML file is a pod. How to create a pod? What is the syntax of pod? Okay, what is the use of pod? Okay, what is the like as how many containers we can run in a pod? All those we're going to discuss in a pod section tomorrow. And later we'll discuss replica set and we'll go for deployment and we'll go for service object. All this we'll discuss one after another. Okay. That's all for today, guys. Thanks.